If you're troubleshooting network problems, there are a few steps you can go through to help determine where the problem might be occurring. One of the first things that you can try is to ping your loopback IP address, and that IP address is 127.0.0.1, and that's the same address on everybody's workstation. That pings the internal IP stack. That way you can see if the IP configuration of the operating system is even set up properly and working the way it should. If that works, you can proceed to the next step, which is to ping the local IP address of the adapter that's communicating out on the network. So ideally, you've plugged in a cable to the back of your computer where your network connection comes in, or you're connecting to a wireless network, and that's the IP address that we're looking for. So we'll ping that local address and see what results we get. If we aren't able to access that IP address, then clearly we have a problem communicating from our machine out onto the network. We don't even have to worry about the other network pieces yet because we can't even ping our own IP address. So check your local IP address configuration, check the adapter configuration inside the computer, make sure that your network cable is plugged in or that your wireless communication is set up properly in the config. If our local IP address is responding to pings, then perhaps we should try communicating to another device on this same subnet. And the default gateway is a device that's generally always turned on and always available on your local subnet. So that's a perfect example to try. So let's get the IP address of your default gateway and let's ping that address. That means that we're now going across the network. We're communicating to a separate device, and that device is communicating back to us. And if we're not able to access that device, that either means that we are not configured properly for our subnet, or perhaps that device itself is not available. So check a few different devices that you know are on that local subnet to see if you get a response from any of those. If we can communicate to our default gateway, then it stands to reason that we probably should be able to communicate out beyond the local gateway. And generally, when we're trying to solve a lot of these network problems, it's communication out to the internet. So one good way would be to ping a device that we know is going to be available on the internet. And a very easy one to remember is the Google DNS server, because its IP address is 8.8.8.8, and it does respond to pings. So this is a perfect example to try to determine, are we able to communicate out to a device that's somewhere on the internet and have that communicate back to us? And we can do that by trying to ping 8.8.8.8. If you've ever been connected to a network that did not have a DHCP server, or that DHCP server was not assigning IP addresses, then you've probably seen that you have had a problem communicating out to the internet or to other devices outside of your subnet. But one thing that our operating systems can also do is automatically assign an IP address even when a DHCP server is not available. We call these automatic private IP addresses, or APIPA. They're designed to be an address that works just on our local link, on our local subnet. It can't be routed out to the internet, so we're not able to communicate to Google and other websites, but we can communicate to other devices that might be on our local network. These IP addresses are reserved. It's 169.254.1.0 through 169.254.254.255. You'll notice that there are some addresses that are reserved there on the end, and that's for future use. These addresses are automatically assigned. You don't even have to think about it. In fact, your machine will send some ARPs out on your local network to determine if another device already has that APIPA address, and if it doesn't, you now have one assigned. If it does find a duplicate, it will choose a different APIPA address, and it will assign that one to your local workstation. So if you are trying to troubleshoot a network and you're trying to find out where am I having a problem, have a look at your local IP addresses and see if you were assigned a DHCP address or see if you were assigned an APIPA address. You can look at some of this addressing by typing an ipconfig at the Windows command prompt, and you get information about the IP configuration of your local adapter. This is an ipconfig/all, so I get to see the adapter and MAC addresses. DHCP is enabled on this. You can see it says, yes, you can get a DHCP address, but you'll notice that an auto configuration IPv4 address was assigned. So obviously we were not able to communicate to that DHCP server, and you can see it's 169.254.228.109, and it's got a subnet mask of 255.255.0.0. So now we know that we did not get a DHCP address, but we did get an automatically assigned address that we can use to communicate on this local subnet. One thing you'd like to avoid on a network is setting a duplicate IP address on devices. You don't want to have multiple devices with exactly the same address, or they're going to have a problem communicating on the network. One of the things that helps is to have a DHCP server, because the server is in charge of assigning IP addresses automatically, and it's not going to assign the same IP address to two devices. But if you are statically assigning IP addresses, you might run into situations where you accidentally configure two devices with exactly the same IP address. Windows and other operating systems can detect when a duplicate IP address is on the network. And if there is a duplicate, pops up a message that says there's a system error, there's an IP address conflict with another system on the network. And at that point, the IP address stack that communicates out that interface on that device is no longer going to work. It knows there's a duplicate and it's not going to put itself back onto the network and allow you to communicate, because it would create a conflict with someone that's already using that IP address. So if somebody's complaining that they can't communicate at all onto that subnet using their configuration of their machine, we might want to check to see if a duplicate may be in place. If we somehow get duplicate devices on the network, they've got exactly the same IP address, then what you'll find is they may have intermittent connectivity, or you may find that some devices can't communicate at all. You have the ARP tables that are configured in certain devices that may be able to talk to one device but not the other. So it may look as if the devices are on the network, but they're not on the network. You have some connectivity from some devices and you have no connectivity from others. So if that's the case, make sure you don't have any duplicate IP addresses. Remove one of those devices from the network, reconfigure the IP address, and make sure that everybody is using a unique IP. One of the most frustrating problems to solve for the network professional is one where the user is saying the network is slow. The problem could be in so many different places, so it's very useful to break the problem down into pieces and start looking at the health and availability of the devices on your network. One thing you may want to check are the infrastructure devices on your network. Check your routers and your switches, and check the internet connection and make sure the bandwidth isn't being overloaded. You want to be sure that those devices have enough capacity to handle the load that's going through them. If you're just putting a device on the network for the first time, you're noticing very bad performance, you may want to check the speed and the duplex and make sure it matches what is expected on the switch. Normally, you'd have configuration set to automatic on your switch and the local device, and those two devices will auto-negotiate and determine what the best speed and what the best duplex would be. But sometimes that doesn't work very well, and you run into mismatches where one device thinks it's running at half duplex and another device thinks it's running at full duplex, and that will certainly create a problem for the speeds and the throughput that's going through the network. A common fix for this is to manually set the speed and the duplex on both sides so that they are exactly the same. This eliminates the auto-negotiation process completely, and you know exactly what the speed and duplex should be on both sides. Sometimes the problem is in the hardware itself. You may want to check your network adapter and make sure it's performing well. Sometimes it's as simple as a cable that's been crimped. You can swap out your patch cable and the network is back and running as fast as it should be. And sometimes our problem is software. These days we are always keeping an eye open for malware and other malicious software that might get installed onto our machines and slow everything down, including the communication that we have out to the network. Wireless networks have their own challenges when troubleshooting, and because these are radio signals, we have to be very sensitive to any problems with interference. Someone may turn on another access point that is conflicting on the same frequency, or maybe the problem is much more of a broad spectrum problem. Somebody might turn on a microwave oven that sends out a lot of interference, and while that microwave oven is running, nobody can communicate on the wireless network. You should also look at a workstation's signal strength. We want to be sure that they're able to hear all of those radio signals so that they're able to send information as quickly as possible. The farther away you are from the access point, the worse the signal is going to be, and the worse the signal is, the lower the throughput on that wireless network. You should also look to see what channel is being used on the access point, especially if you're using multiple access points in a very close area. Make sure that the frequencies aren't overlapping so that you don't have any issues with interference that's being caused between your access points. Another problem you run into, especially in environments like an office building, are things like frequency bounce and latency. If there are flat surfaces and places where that signal can bounce around, you may run into situations where you're having multi-path interference, where the signal actually shows up in multiple paths at different times onto the radio antenna. Another thing to look at is where the access point might be placed. You want to have it, of course, as close to the user. So if you're running into situations where the only physical place you could mount the access point is farther away from your users, it may be time to try to find some other options to get that signal as close as possible to your user community. Sometimes you can predict where this interference is coming from. You can look at fluorescent lights. You know there is a microwave oven. You know there are cordless telephones in use, and you can mitigate those. You can change out the model of microwave you're using. You can use different telephones so that you can keep those interference to a minimum. Sometimes you have no control over this, especially in office buildings where there are many tenants. Everybody wants to bring up and use their own access point. And in those situations, you could have frequency overlap that can cause interference on that wireless network. So sometimes it's useful to work with the people that are in your building to assign what frequencies might be available to them, or just keep an eye open and see when someone adds a new access point, see if you can change your frequencies so that you're not conflicting with someone else who's using an access point somewhere close to you. Some of these checks you can do with built-in tools that are in your operating system, like a signal strength meter that's on your wireless access point, and you can see throughput and performance when you use Windows Performance Monitor. Sometimes you might want to use a third-party tool. There's a lot of free tools available to check who's using the network, especially on a wireless network, or maybe it's something that is very advanced that can give you information about the entire spectrum, throughput, all of the devices that are on the network, signal strengths, and much more. By using some of these network troubleshooting techniques, you can be assured that your users are able to perform whatever tasks they need on the network.